So in this video, I'm going to go over some problems that are very similar to the problems you'll be asked to solve in your homework. And we're going to be using a lot of the properties of exponents and radicals that were covered in the first three videos, so make sure you've watched those and understood those. So the first problem we have is this guy here. And we are asked to simplify the following radical expressions. So there's a few ways I can do this. To make it as clear as possible, I will first use this property here to rewrite this radical as a fractional exponent. So I will write 16 a to the fourth b squared all to the 1/2 power. Now I can use this property to distribute my 1/2 exponent over all these quantities. Note that these are all forming a product. This is not a sum. Remember, exponents do not distribute over a sum. So this will become 16 to the 1/2 times a to the fourth to the 1/2 times b squared to the 1/2. Now I will use this property for this guy and this guy, where I've got an exponent on the inside and an exponent on the outside. And I'm going to need to multiply those using this property. Here I've got 16 to the 1/2. Now remember that 1/2, or more generally 1 over n, equals the nth root of whatever base you have here. So this is secretly asking us for the square root of 16, which we know is 4. Now this we will have a to the fourth to the power of 1/2. Using this property here, I will have a to the fourth times 1/2, which will be a squared. Here I will have b squared to the 1/2, which will be b to the 2 over 2, which will just be b. And this is our final answer. Easy enough. Okay, now we're going to move on to this, which is slightly more complicated. We will need to remember that a radical distributes over a fraction. Since the last one, I used the property of changing a radical to an exponent. I think I'll do this one without doing that, just to show you can do it both ways. So I will rewrite as square root of 4a squared b over 4 over the square root of 16. Now this square root will also distribute over this whole product. So I will have the square root of 4 times the square root of a squared times the square root of b to the fourth. In the denominator I have the square root of 16, which is just 4. The numerator, I have the square root of 4, which is 2, the square root of a squared, which is a, and the square root of b to the fourth, which will be b squared. And the denominator is as simple as it's going to get. I can now cancel this 2, cancel this, and write the 2 there. So my final answer will be, if I write in order of descending powers, b squared a over 2. Okay, now let's go ahead and go to this. Oop, that's not what we want. There we go. Okay, Now this guy we are asked to convert to a fractional exponent. So for that I will use this property here to first rewrite this as 3, pen's a little too big, 3r to the 6 to the 1/2 power. Now I will use this property, which allows me to distribute this exponent. So I will get 3 to the 1/2 times r to the 6 to the 1/2. Now for this guy here, I will use this property. The 3 to the 1/2 is the simplest it's going to get, so that's just going to stay the same. This I will have r to the 6 times 1/2, which will be r to the 3. And that is my final answer for that problem. Okay. Now finally, we are asked to convert a decimal exponent into a radical form. So to do this, I am first going to convert it into a fractional form. And that will make it easier to convert it into a radical. Now you can sometimes convert these, for example, if it was 0.25, instead of writing 25/10, I could write 1/4. In this case, I don't know of a fraction. It doesn't look like there is one. That's going to be simpler than this. 17's prime, so I know that's not going to simplify. So if you can, you want to make sure to simplify this, because it's pretty hard to simplify it once it's a radical, whereas when you've got it in this form, it's pretty easy to see how to do that. So from this point on, I will use not quite this identity, because I don't have a 1 here. I got a 17 here. So I'm going to use this more general form. It should be noted that this is a redundant form of this. I write that now just so that it's easier for you to see. In the future, we don't need it. It's derivative of this. So if you know this, you also know that. Anyway, using this property here, we see that we're going to get the 10th root of x to the 17th power. Now this is in radical form, so this is our final answer.